All right, so let's real quick just go over the 3 reactions that you just did. And I'm just call on you randomly, have you tell me what the precipitate was, and maybe read to us loudly so Addie can hear it, your balanced chemical equation. Max, what'd you guys find the precipitate to be in number 1?
The barium sulfate.
Okay, so the precip equals barium sulfate. Is that the correct formula for barium sulfate? Yes. All right, Carter, really loud, read me your reaction.
Aqueous BaCO2 plus K2SO4 yields BaSO4 solid plus 2 KCl.
Okay. You guys agree with him? All right. How about, Lauren, what was the precipitate for reaction number 2? Okay, so no precip. You guys agree with her?
C.
Okay. What about here? Maddie, really loud, read your reaction. What state? BaNO3 twice in what state? Okay, aqueous. Okay, everybody agree with that? All right, Avery, what was the precipitate in the last one? Okay. Did I tell you? I did. So FeOH3, and Colin, read me your reaction really loud.
Aqueous Fe2SO4 3 plus 6 LiOH aqueous form yields 2 FeOH3 in solid form plus 3 Li2SO4 in aqueous.
Okay. Agreed? All right. I don't know if you can read that, Addie, but there you go. You can check your paper with that after you finish. All right. All right, so now I'm going to show you a new word, new kind of reaction. Well, you really already know the reaction, but there's another name for it. Oh no, I'm just getting started. Metathesis? No, I have not. I need to run stuff off. Metathesis reaction, that's a new name. This is also called an exchange reaction or double replacement, which is the way we've learned it so far. In chemistry, it's often called metathesis reaction when we're talking about ionic equations and net ionic equations. And the reason it's called that is because really this meta with thesis means to transpose. It's some of your Greek roots. To transpose. So just like, where did I put that paper? In that last reaction, where these things were transposing, they're switching places. So that's why lots of times they're called metathesis reactions versus double replacement reactions. And then I gave you guys this, which is really like a long list of the way to work through some of these problems. I would hang on to that because this unit's kind of long, and most likely what we'll do is quiz over this stuff before we move on to the acid and base stuff. So when we're working with these things, there are different ways to write the equations. The first way is the molecular equation. And that's pretty much the way we've been doing it. It's the reactants plus the product, or yielding the products balanced. It's exactly what we've been doing all along. That's called a molecular equation. So it's nothing new. If you're asked to write the molecular equation, you write what we just did. Alright, so what I want you to do underneath this, I'm going to put this up here. You don't need to write this in your notes, you just need to write the equation in your notes. So do that one all by yourself. Pull out your little card again. If you put it away, you're going to have to use it. I guess you're not. I told you what it was. Darn. So you're just writing you're writing the equation. I'm so used to writing state in there that I put it in. So write the molecular equation. That's what I would say to you on a quiz or a test. If I were wanting you to write what we've been doing all along, I would say write the molecular equation, balance the equation. And it should go, like from here forward, when you're told to write an equation, it should be a balanced equation. I was amused by you. What?
Where does chloride
Yeah,
come from?
seriously.
What?
Iodide and chloride.
Solvent, chloride, chloride.
Lead chloride.
Wait a minute. I don't understand your question. Lead nitrate reacts with aqueous potassium iodide. Oh, well, I messed up. I do that. Well, now you can't read that either. Lead iodide and potassium nitrate. Sorry, thanks. I should say. So anyhow, what I was going to say is, when I ask you for examples on the types of reactions on the test, some of you left the examples out. Oh, I shouldn't be talking about this right now. Never mind. Well, I'll retract that. We'll talk about it tomorrow. Do we have it written? Not yet? Okay. I see exactly what I did. Okay, Kinley, give me the first reactant. All right, Clark, give me the second. Okay, I. Aqueous, solid, what is it? Aqueous. All right, and then I get to the other side of the equation, and I even gave you what that was, sort of. I tried to confuse you. Annika, what goes on the other side? Now, first let me ask you, does everybody agree with this? No. What don't you agree with? There's one thing I don't agree with. The 3 should be a 2. Okay. Because up here, my nitrate I know is 1 minus, and there are 2 of them. So that told me that had to be lead 2. And did I tell you in the, and I also told you in the thing, I couldn't remember. All right, is this balanced? No? So, oh, I heard from today. Stuart, what do I have to do to balance this? Okay, so this is an acceptable molecular equation. So when you're asked for that, don't be confused. That's what we're looking for. Okay, the second type, which is, I don't like these, but they're sort of a necessary evil, I guess. It's called a complete ionic equation. So in a complete ionic equation, all strong electrolytes and I could say strong acids, strong bases, soluble ionic salts, you know, all those words that fit strong electrolytes are dissociated, I'm going to just say into their parts. Where did I write that down at? So let's take this last one. You wrote this lovely molecular equation. Now we're going to take it and we're going to make it a complete ionic equation. So let's look at what we do. And I'm just going to go through this one for you. I would take that whole reaction, which I can't show both of them at once, but you've got it in your notes. And I would have Pb 2 plus AQ plus 2 NO3 minus AQ. All I did was separate the first compound, plus 2K plus 2I minus, and both of those were also aqueous. So I've taken it and separated it into its ions. And then to yield Pb 2 plus solid plus 2I minus solid plus 2K plus aqueous plus 2 NO3 minus aqueous. So not only have I separated them, I've carried their coefficients through. That's called a complete ionic equation. It shows every ion and it shows their state. So this really, like, I will say most correct way to represent the species, that's what we call them, present in aqueous solution and reaction mixture. And we call that a mixture when those solutions come together for the reaction. It's a little bit different than how we normally think of a mixture. So each one of these would be called a species within the reaction mixture. So if I were to say, give me an example of one species from this reaction, you could pick any one of those 8 things and be right. So we have a molecular equation, we have a net, or we have a complete ionic equation, and then the last one I'm going to show you today, bless you, is called a net ionic equation. Any questions over this at all? told you this would be a nice little break from what we've been doing. So then the last thing, or the last one I'm going to cover today, is called the net ionic equation. All right, so this one is one you have to actually think about and think about what you're going to do. So the first thing you're going to do when you write a net ionic equation, you're going to want to take your complete ionic equation and cross out or put an X through, however you want to say it. Anything that doesn't change form from one side of the equation to the other, or from the left side of the equation to the right, however you want to say it. The things that you cross out are called spectator ions.
Because they're just there.
What?
They don't do anything.
Yeah, they help in the reaction, but they don't change form, so we call them spectator ions. They don't become part of the solid, in other words. So, once again, I'm going to find my paper. And I'm going to look at this. So let's go back. You should have this in your notes. And you really do have to just start with each one and say, okay, my lead 2 started as aqueous. What is it on the other side? It's a solid. So I don't want to cross it out. Then I go to my nitrate. Okay, it was aqueous on this side. It's aqueous on the other side. So
But you'd rewrite it left or right.
I will in the end, yeah. And then I move on to my next one. My potassium, aqueous on this side, aqueous on this side, so I can get rid of it.
Do you actually cross it out or just leave it out?
What do you mean?
So you write it just like a complete ionic equation and then cross it out?
Or
You can if you need to, but I don't really care. I'm just showing you with this. Like if you really want
Do
to,
a fresh new one?
we will. If you really want to check yourself, I'd put a line through it. Like I would work my way through it. Okay, so then what do I have left? Iodide, aqueous on this side, but solid on this side. So now I'm going to take those and I'm going to write, now that I've crossed things out, I'm going to write my net ionic equation. So from this reaction, my net ionic equation would look like Pb 2 plus, oh, gotta put my AQ in, plus 2I minus yields, doggone it, aqueous, yields yields Pb 2 plus solid plus 2I solid. These are your participant ions. You might be asked about that. You might be asked about your spectator ions. So anything you crossed out here, you would name as a spectator ion. Make sense? All right, now, I have no idea where that paper is. you would have to write, like if I ask you for a net ionic equation, all I want is this. Myself, I'd write the equation first and get rid of them, but when where you're putting your answer, if I say box off your answer, that's all I want to see. But when I'm grading it, will I look at the whole thing? Yeah, I'll look for where you went wrong, so maybe if you are wrong, I can give you a couple points, like I always do. Okay? Pull out, or you probably still have it out, I just don't know, here's mine. So let's just take example, let's go back to our lab groups, and let's take examples 1, 2, and 3, and write them as net ionic equations. And then we'll come back together again.